Let us understand how to sketch reciprocal function. In this example, we'll sketch reciprocal of a linear function. The question is, sketch linear function f of x equals to x minus 2 and its reciprocal. So in the first part, let us sketch the linear function f of x equals to x minus 2. Now to sketch a linear function, we can adopt two methods. One is, let us find x and y intercepts, right? So we can find x-intercept and y-intercept. X-intercept is a point where y is equals to 0. So if you put y equals to 0 in the equation, what do you get? You get x equals to, let's put y equals to 0, we get x minus 2, and from here we get x equals to 2. So this gives us x equals to 2. Right? So that is the x-intercept. For finding the y-intercept, we have to put x equals to 0, right? So we have x equals to 0. If I put x equals to 0, I get y equals to minus 2. So these are the two critical points. We can always draw these 2 points, plot these 2 points, connect the line, and get the linear function, right? So that is one way of doing it. So the 2 points are 1, y value is 0 and x is 2, so write 2 and 0 here, and the y-intercept is 0 and minus 2, right? So 2 and 0, so that is the first point, 2 and 0, and the y-intercept is minus 2. So we can join these 2 points and get a line, right? So that's one way of doing it. The second way of doing it is slope-intercept form. Now y-intercept is minus 2, so we can start from minus 2, right? So that is our y-intercept, minus 2. And slope is 1, that means from here rise of 1, run, rise, run, rise, run, rise and run. So you can do down 1 and left 1 also. So you can get a line by plotting these points and then join them. In either case, both will give you the same line, right? So you can adopt any one of those two methods to draw a line. So that's the first part. So here we have a line. Now this line is our function f of x, which is, I can write here as y equals to x minus 2. So that is the first part, and that is line, right? That's the first part when we have sketched the line. And I hope you have understood both the methods. One we did with the help of intercepts, right? So let me write down here, this one is with the help of intercepts. And the other one we did with slope and intercept. Right? So this was our intercept, and then we went slope, 1, 2, 1, 2, like that. Now that's the first part. The main part here is, of course, to sketch reciprocal of the function. So now let us understand how to sketch the reciprocal, right? So let's do reciprocal. So when we do reciprocal, if we say r of x is the reciprocal of the function, that means 1 over fx. That is the reciprocal, right? So we can write this as 1 over x minus 2. So that becomes the reciprocal of a function. So let's discuss how to sketch reciprocal of the function. Now we'll look into a few critical things to sketch this function. One of them, let me put some points here so that we'll look into those points. One of them is vertical asymptote. Now vertical asymptote is a point where denominator is 0. That means x minus 2 equals 0. So we have it at x equals to 2. Now this part is not in our domain, and we can always say reciprocal function has a restriction that here x cannot be equal to 2, right? Since if I write x equals to 2, denominator is going to be 0, and 1 over 0 is not defined. And therefore, at 2 we have a vertical asymptote. So that's the vertical asymptote. So let me draw it with a dotted line here, and that is how it is. So this is vertical asymptote, which I can write as x equals to 2, right? So that is the point 2. Now the second thing is about the horizontal asymptote. So let me write horizontal asymptote. That is, when x approaches positive infinity, what happens to y? Y approaches what? So as you can see, as x approaches positive infinity, the line approaches positive infinity. And 1 over infinity, or 1 over approaching infinity, is approaching 0, right? So we know that since it is approaching positive infinity, it is going to approach 0 from the positive side. So as x approaches positive infinity, y approaches 0 from the positive side. So that is y approaching 0 from the positive side. Now what happens when x approaches negative infinity? That means this side. As you can see, the line approaches negative infinity as x approaches negative infinity. Now reciprocal of negative infinity is of course 0, but that 0 is from the negative side. So we represent it by this sign, right? So here it approaches from the negative side. So that is how the function approaches or behaves, and that is also called the end behavior, right? Now after understanding the end behavior, let us understand behavior near the asymptote, right? So now we'll say behavior near, let me say vertical asymptote, right? VA for vertical asymptote. Now that means as x is approaching, vertical asymptote is at 2. As x is approaching 2 from the left side, that means minus left side. This is from left. Now x value is negative. It is approaching 0. 1 over 0 is infinitely large, right? So it is approaching infinity, but towards negative side. So here the behavior is that our function is actually approaching infinity, and that too towards the negative side. So it is approaching in this direction. Similarly, if you consider x approaching 2 from the positive side, that means from the right side, then y is approaching infinity, but towards positive infinity side, because x, as x approaches positive value, the function f of x is positive, and therefore it approaches positive infinity. So that shows behavior near the vertical asymptotes. Then another critical point which we should consider is invariant points. What is invariant? Invariant points are points which are common to both. They are common to fx and reciprocal, right? And rx. So that happens when y equals to 1. So when y equals to 1, we have these points, right? Let me circle them for you. When y equals to 1, reciprocal of 1 is 1, and reciprocal of minus 1 is 1. So this is when y equals to minus 1, right? So I should write y equals to plus and minus 1. So reciprocal of plus and minus 1 is actually plus and minus 1. It's the same point. Therefore, that is going to be a common point between the two x's, correct? So that is a very important point to consider. And then we can also consider points like when x is 0. In this function, when x is 0, what is r of x? That means r of 0 equals to what? We can write r of 0 is 1 over 0 minus 2 or minus half, right? So at 0, we have minus half. That is, the y-intercept for the reciprocal function is minus half. So that is another critical point to consider. Now with these points, we can always connect them and then draw the reciprocal function. So we know the behavior, so we can say connect these points like this. We'll go through the invariant point and then towards negative infinity on the left side. On the right side of the curve, we can connect the same points going through the invariant points and then towards 0 from the positive side. So that gives us the reciprocal graph. I hope These steps help you to find or to plot a reciprocal of a function. You can of course take few more points and make it more accurate, but if you do these 5 things, then you get fairly good accurate reciprocal function. I hope you understand. Let's just recap. So first we drew a line. You could draw a line using x and y intercepts or using slope and intercept. Once you draw a line, then see where the line crosses x-axis. At that point, the value of y is 0. So the reciprocal will be 1 over 0. 1 over 0 is not defined, so this part is not in the domain of reciprocal function, right? So remember, the domain of reciprocal function is x belongs to real numbers, but x is not equal to that particular point, which is minus 2. So at this point, we have a vertical asymptote. So first thing, sketch vertical asymptote. Second important thing is the end behavior. As x approaches infinitely large value, whether positive or negative, y approaches 0. So that gives us horizontal asymptote. So we can also draw a dotted line here, signifying that we have a horizontal asymptote at y equals to 0. Third, we have to check the behavior near both the asymptotes, horizontal and vertical. If you are approaching from the negative side, that means you are in the negative half of the third quadrant. If you are approaching from the positive side, then you are on the first quadrant. That is kind of important to understand, right? So behavior near the asymptote is described here, which I hope you understand. So we have to see behavior for both the asymptotes, when you are approaching plus and minus infinity, and when you are approaching vertical asymptote from left and right. When you are approaching from left in this case, as you can see, the line is negative. The function approaches negative infinity. But when you approach vertical asymptote from the right, the line is positive. So you approach from the positive side. And then you can sketch your function. A good check on the function is, since our line is always increasing, you'll find that the reciprocal is always decreasing. So that's a good check. So let's write it down as what we get from the graph. Say, since line is increasing, reciprocal is decreasing in its domain. That's kind of important to note that x equals to minus 2 is not in the domain, right? So except for that point, it is decreasing, you see. As you move from left to right, your function actually decreases. So that is kind of very interesting observation which you can make from this particular graph. And second, you have invariant points. Invariant points are points where y value is plus 1 or minus 1, right? So at both these points, we have common, these points are common to both the graphs of a function and of reciprocal function. So I think that completes the sketch of a reciprocal function. So we'll take more examples, and this time we'll take on quadratic function and see how to sketch reciprocal of a quadratic function. Hope you appreciate it. Thank you.